Hi everyone, with Kelvin here. So let's discuss about Biweekly contest 14. Third question, delete 3 nodes. So given a 3 root at node 0 and 3 variables here. So the variable number of nodes and then variable value I. So node I have value of what, and node I have parent, what is the parent. And the task here is we need to remove every subtree that have the sum values of 0 and return the number of node remaining there. So take a look on the first example here. Here this subtree have a sum of -2, -1, and +4. So this entire subtree will have the sum of 0. So we will remove this entire subtree. And also here, node 3 have value of 0. So we will also remove it because this entire subtree is also 0. So we will have 2 nodes left there, and we return the number as 2. So notice here in the variable, we have a variable called parent. So from this parent, we actually can have the reverse relation here. So we can say node number 0 have 2 child, node number 2 have 3 child, and node number 1 have 1 child, right? So what I do at the first is I create a map of certain node have who as the child. So I loop through every nodes and say parent I as the node, and then I will add the node I as the child. So instead of a reference to parent, I have a map to know this node have how many child. And then basically after that we can do a normal DFS. So I separate the function into two. First one is called sum up. So this one basically will count the sum of value on each of the node there. So here, as you see, we will iterate through all the child and then sum up all the value from the child, including its recursion here, and then add up with its own number and then return it as a total. And basically I store it in the hash map of sum. So this sum, the key is the node number itself, and the value is the sum of every child it have. And after that we do a method called checkup. It's also basically the same. It's DFS also. So we check if the sum of value of that node is 0, then basically we return a zero number of node. But if it's not 0, then at least that node itself is non-zero sum, and then we will need to go through all the child it have. So we still use the child map here and loop through every child and do a checkup and add it to our total, because every node inside the child of current node, if they are also having a non-zero, then we will need to add it up, and after that we return the total of the checkup. So the key here is when the sum is 0, we should terminate the recursion, so it's not going down. So that's it for this question. Thank you for watching. See you on the next weekly contest.